Hi guys, welcome to Science with Ganesh. Today I'll be explaining Igcse Chemistry 0620 Topic 11 Organic Chemistry Part 1. So let's start. Formally, functional group and terminology. So in this part 11.1 we learn about the different terms and the definitions, the general formulae, and also about the general characteristics of homologous series. So let's start with the definitions first. um, Terms and definitions. Displayed formula. So displayed formula shows the arrangement of all the atoms and bonds in a molecule. Structural formula is an unambiguous description of the way the atoms are arranged in a molecule. Functional group is an atom or group of atoms that determine the chemical properties of a homologous series. And homologous series is family of similar compounds with similar properties due to the presence of the same functional group. Saturated compound are molecules which have carbon-carbon single bonds, and they do not have any double or triple bond, they have only single bonds. And unsaturated compounds have carbon-carbon double bond, or they can have a triple bond. Structural isomers they are the compounds with the same molecular formula but different structural formula. General formula of homologous series, alkanes is CnH2n plus 2. N is the number of carbon atoms. So let's say if the carbon atom is, there are two carbon atoms. So C2, then H, 2 into 2 is going to be 4, plus 2 is going to be 6. So C2H6 will be the formula of the alkane. That is, yeah. And same goes for alkenes. Alkenes has the general formula CnH2n. So whatever carbon number you have, you just need to substitute on the value of n and you will get the formula. Then alcohols is CnH2n plus 1 OH. And carboxylic acid is CnH2n plus 1 COOH. Okay. These are the general characteristics of homologous series. So all the homologous series have these characteristics. So same functional group. All alkenes, all alcohols, all carboxylic acids will have the same functional group. They will have the same general formula. They will, like, each member will differ from CH2 unit. So let's take an alkane. The first is methane. So methane is going to be CH4, right? And ethane is C2H6. So if you see, we have just added one C and one H2, which has given us the next unit. So each member is similarly differing by CH2 unit. Now it displays a trend in the physical properties as the number of carbon atoms keep increasing, the boiling point increases, the melting point increases. They have similar chemical properties. Now the chemical properties of methane, ethane, propane is going to be same. I hope you got this slide. So let's go to the next. Now 11.2, in this we'll be learning about naming the organic compounds. We'll also see the displayed formulae of different compounds. So let's start. So naming organic compounds. The prefix, which is the beginning part of the name, shows the number of carbon atoms present in the compound, and the suffix, which is the end part of the name, shows the homologous series to which the compound belongs to. For say, we need to name an alkene, and the number of carbon atoms present are 4. So 4 means the prefix is but, and it's an alkene, so the suffix is going to be ene, so butene. So an alkene with 4 carbon atoms is going to be butene. Then when naming alcohols and carboxylic acid, when we need to say that that alcohol has 2 carbon atoms, so we don't say ethyl, we say ethanol. We need to just add an N, ethanol. Okay, and when carboxylic acid, if it has like three carbon atoms, then you can just say propanoic acid. So that means it is a carboxylic acid which has three carbon atoms. I hope this is clear, and it is very important to know how to name an organic compound. So displayed in molecular formula of alkanes, methane has the molecular formula CH4, and this is going to be its displayed formula. C, you can see H, 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 so CH4. Now, all the carbon atoms will form four bonds. That's an important point to remember. All the carbon atoms will form four bonds. You can see here this one carbon atom. It's forming a it's forming a bond with three hydrogen atoms and another carbon atom, which means it has completed all its four bonds. And in this carbon atom, that's also forming a bond between three hydrogen and one carbon. So this is the way ethane, propane, butane, pentane, and these are the molecular formulas: CH4, C2H6, C3H8, C4H12, and C5H12. Next, structural and discrete formula of alkenes, sorry. So ethene, this is going to be the structural formula. As I told you, structural formula is an unambiguous way of showing the way how the molecules are arranged. So here it is written CH2 double bond CH2. So see CH2 double bond CH2 double bond CH2. So that's the same thing which we wrote in a simplified form. Instead of drawing the whole structure showing all the atoms, we have just written it in CH2 double bond CH2. Now here CH2 double bond CH3, that's propene. So you can see that it has CH2 over here. There is the double bond, and here is the double bond. CH and then CH3. So we have again written it in a simplified format over here. So we do the same thing over here, and one more thing, when we put the double bond over here, this is going to be but-1-ene because the double bond is between the first carbon. When the double bond comes over here, it's going to be but-2-ene. So yeah. And the way you can know that these atoms are alkenes, you can see that they have a double bond between each, between two carbon atoms, there is a double bond. So that means that it is an alkene. Alkanes won't have a double bond. Alkanes are saturated compounds. They only have a single bond. They do not have a double bond. But alkenes do have a double bond. And alkenes, there is no methane because when there will be methane, there is only one carbon atom, so there cannot be any double bond, which means so there is no methane. So it starts from ethene, propane, butane. Methane does not exist in the alkenes. Next, structural and displayed formulas of alcohols: methanol, ethanol, propanol, butanol. So this is CH3, CH3, CH2OH. Same way we are writing it in a simplified form, and this is the displayed formula which is showing all the bonds, all the atoms in the molecule. So as it is having the OH over here, this shows that the OH is showing that it is an alcohol. All alcohols will have the functional group OH. So anywhere you see OH in the structural formula and the displayed formula, you can easily say that it is an alcohol. And if they give you the name, then obviously you can see when there is an "ol", it is alcohol. So next now is carboxylic acids. So carboxylic acids have the functional group COH. So in a distillate formula, when you are given this structure, you can say that this is a carboxylic acid because it is having a COH, which is the functional group. And in the name, you can know that it is OIC because it has the OIC. You can say it is an carboxylic acid. Same over here in the structural formula also, wherever you see COOH, it means that it is an carboxylic acid. Now esters. Esters are the sweet smelling fragrances like perfumes which we use. So they are like esters. Now esters are formed when alcohols reacts with carboxylic acid. So when ethanol reacts with propanoic acid, it forms ethyl propanoid. The name becomes ethyl propanoid. The alcohol part is going to get an "-ile", and so it's ethyl, ethanol becomes ethyl. And for propanoic acid, we just cut the OOic and we get O8. Instead of OIC, we write O8. So it becomes ethyl propanoate. Now you can see that over here water molecule has been removed. So COO and here comes the O. And when you see this type of linkage, this type of bonding, you can say that it is an ester. Then butanol and methanoic acid. Now butanol, again, when we remove the anol, we are going to write "-ile" there, so butyl, and here we'll remove the OIc acid and we'll write O8, so butyl methanoate. Same goes for this pentanol and ethanoic acid, so pentyl ethanoate. Okay, I hope this is clear. We'll be learning more about esters in the coming parts. Now fuels, we'll learn the different fossil fuels. We'll learn about the fractional distillation of petroleum and the different uses of the fractions which we obtained from the fractional distillation. So first of all, coal, natural gas and petroleum are the fossil fuels, and methane is the main constituent of natural gas. Hydrocarbons are compounds containing hydrogen and carbon only. So alcohols and carboxylic acids are not hydrocarbons as they have oxygen as well. Alkenes and alkenes are hydrocarbons because they have only carbon and hydrogen. They do not have oxygen, they do not have nitrogen, they do not have chlorine, bromine, they do not have any of these. They only have carbon and hydrogen. That's why it's a hydrocarbon. Petroleum is a mixture of different hydrocarbons, and we need to separate this petroleum to get fractions which can be more useful. So let's see the fractional distillation. This is the fractional distillation of crude oil now, that is petroleum. In that we get bitumen, lubricating oil, fuel oil, diesel, paraffin, naphtha, gasoline, petroleum gas. So what happens? The petroleum goes through a furnace where it is heated at a high temperature, and the one which is getting heated very quickly with a low boiling point, it goes as a gas, and that's petroleum gas which has the least boiling point. That's why it leaves the furnace over here. Then next, which has a greater boiling point than petroleum gas, which is gasoline, then that leaves. And this continues, and bitumen has the highest one, and that's why it leaves the fractionating column at the end. As you can see that it reaches up to 350 degrees Celsius. So these are the properties of the fractions. As I told you, that the boiling points are lower at the top, and at bottom the boiling points are high. Decreasing chain length, the carbon chain length keeps decreasing when you go from bottom to top. When you go from bitumen to petroleum, the carbon chain length keeps on decreasing. And that's the reason they have low boiling point, because the carbon is less. There is, less forces, less bonds to break. Higher volatility is volatility increases from bottom to top. However, the viscosity, it decreases. Viscosity is like how viscous, how thick the compound is. So at the top it's very less thick, but at bottom it's quite thick. Now these are the uses. These need to be memorized. Refinery gas is used for heating and cooking. Gasoline or petrol is used for fuel used in cars. Naphtha is used for chemical feedstock. Kerosene or paraffin is used for jet fuel. Diesel oil or gas oil is used in diesel engines. Fuel oil is used for fuel used in ships and home heating systems. Lubricating oil is used for lubricants, waxes, and polishes, and bitumen is used for making roads. That's it for this part. We'll continue organic chemistry in the next part. Thank you so much for watching this video, and please like, share, and subscribe.